Hi, this is Sean Bodley with Clear Technologies. I'm a senior IT consultant and a five-time IBM champion based out of Dallas, Texas. And I'm about to present an introduction to PowerHA Enterprise Edition utilizing GLVM and give a demonstration utilizing a cluster I have set up in my lab. Now, this particular combination is not even remotely new. I'm talking to you in May of 2020. And this combination has been supported for at least a dozen years. And so you may be asking yourself, if it's nothing new, why am I presenting this today? Well, it's actually quite simple. Somebody on my YouTube channel simply gave a reply to one of my videos that I have and asked for it. So this was actually something I already have set up in my lab. So I figured it would be pretty easy to accommodate. I just threw a couple of quick slides together and figured I would cover it at their request. So what GLVM is Geographical Logical Volume Manager Mirroring. That is IP-based replication. Now this actually comes with the AIX operating system, so you do not need PowerHA or PowerHA Enterprise Edition to use it. What PowerHA does for you is automate the failover in the event of a disaster and you need to failover between sites. You can actually set this up and implement it and manually flip over anytime you wish. It's just by default, the GLVM file sets are usually not installed when you install AIX. There's additional GLVM file sets needed that you'll probably go pull off install media and install yourself. As I mentioned, this is not a how-to video on how to configure it. There's plenty of documentation on how to do that, the base pubs and a couple of the PowerHA Red books. We cover GLVM quite extensively. There's also a two-node configuration wizard provided within PowerHA to help configure GLVM. So what this is showing here is on the left side would typically be your production site, and the right side is actually your DR site. Now, typically it seems a little strange that your local prod would be client and your remote DR site would be considered something called server. Well, that's because this stands for remote physical volume. So I need to serve up a remote physical volume to the local prod machine. So that is the actual server and the prod machine is the client. So like I said, this is IP-based only, which means it is storage agnostic. It's not using any of the storage replication features. This is all done through the operating system. And what this does is it actually presents a disk locally at the DR site to appear locally on the production site as though it is an attached disk. But the only way it can communicate with it is across the IP network. So you actually have to set up what's called an RPV server and client relationship for each physical volume. And when you do so, once it shows up and is available on the primary site, it's almost identical to just configuring LVM mirroring at this point. So each site would have one complete copy of the data. So here is just a rough overview of what my lab environment is like. I have a couple of Power9 S914s using AIX 715 SP1, HA723 SP1. And even though I have V7000s, which happens to be IBM, it really doesn't matter. This can be used for any storage type that is supported, attached on the power box. The only real caveat to this is you can't use it for root VG. So it's for data volume groups only. And in most cases that people do any kind of replication, typically mirroring or replicating the OS presents a different set of challenges in its own. In this particular case, I have customers that they use other utilities to keep some of the system files and user group password type stuff in sync, and one of the most common being simply using rsync. So just like the rest of my videos, here's a handful of pubs that may be helpful in your quest, usually going to the Redbooks website. We have quite a bit of PowerHA and GLVM information in the Redbooks themselves. So with that, I'm going to switch over to the two nodes in my cluster. I have nodes Jessica and Jordan, and Jessica is actually the primary site and system, and Jordan is the secondary. So currently, my cluster is up and running, and it's available on. It's a stabilized cluster, but I just wanted to show a couple of things before I actually do a failover. And one thing is I mentioned something about this remote physical volume and client relationship. So you can see here that HDisk4 on my primary system says it's remote physical volume. That physically does not exist on this system. It is actually the disk over on Jordan. So if I look over here, GLVM VG is not active because it's running on Jessica, not Jordan. And here's the disk that ends in 2291. And I can see HDisk4 ends in 2291. But remember, these are not physically shared. It can only get there through the IP network. So locally, this 337 disk is a local disk on Jessica. And having said that, if we did a controlled failover to node Jordan, it would do a little role reversal, and it would use the disk from node Jessica. So in this case, HDisk4 would be this 337 disk. Well, because it's currently not running over there, that disk is not available, and you can't really see it right this minute. But when I do a hard failover, you're going to actually, you're not going to see it become active. It would only be a soft failover or a controlled RG move. You'd see it become active. On a hard failover, it can't access the remote disk. It can only access the disk locally. And in that case, what it'll do is do a force virion in the volume group to activate that volume locally, and you can get to your data. So in this case, in my cluster, my clustered file system is called BMOFS. So if I go to BMOFS, I'm just going to create a demo text file. Put something in it, save it. Now, BMOFS currently does not exist on node Jordan because GLVMG is active on Jessica only. So now, if I actually halt, I'll do a hard halt on Jessica, reboot -Q being my favorite. That actually will essentially do a halt and start a reboot automatically. Now that system actually reboots in a couple of minutes, so my cluster status will show that that system comes back alive pretty quick, even while the takeover is in progress. Now, this right here says the resource group is online secondary. It technically isn't. This is actually a normal starting point that you would see that's actually left over from PowerHA XD back in the days of something called HAGO. It's technically not online over there at all. It really just says, I'm ready to take over in the moment of need. So I'm using a tool here called QHA, and now it says it's online. It doesn't say that it's online secondary. It took over the service IP address. And if I look, I've got BMOFS listed over here. So now if I change over to BMOFS, and look, there's my file. And if I cat the file, I can see that the contents of that is there. But if you look, I only have GLVMG. Now it tells me both of them are active, but it's really not because I cannot access the disk on the other side. So if I look at this, GLVM-VG, I want to check the physical volumes, it's going to tell me that it's missing. Disk is missing. So what it does, whether it's a controlled failover or a hard failover, it'll actually do a make dev and make that device available. It'll attempt to do a virion VG of the volume group. And a normal virion VG by itself may not actually work, depending on your quorum status. And in some cases, you'll actually have to do a force virion, and that's actually a setting within the resource group itself that you can tell it to do a force. So you can see that it's open stale, and it's stale because this one is missing, and that's completely normal. So if I restart this one, we can see that he's just in the init mode. I can actually have him rejoin the cluster. I want to start node, not start the cluster. And another thing that HA will do for you is that once the original system becomes active back in the cluster, it will actually auto check every so often to see if it can access that disk again. And I don't remember exactly what the timed interval is, but it'll check it on a periodic basis. And once it becomes available, you technically don't even have to manually resync. It will detect it and do it for you. Now, there's nothing that prevents you from testing that you can L query the disk from where it's running at and reactivate the volume group, and it go out of the missing state and it'll start auto syncing. However, HA will do that for you. So I'm just going to wait for this to join, and then what I'm going to do is wait and see that it syncs up. And once it syncs up, I'm going to probably just write something to the file again and then do a controlled move to the other side to just show you that the write has taken place. And that'll pretty much be the extent of the demo. So now Node Jessica has rejoined the cluster and has taken on the role of online secondary. That just means it's a viable candidate to fail over to now. You can actually have a setting to have it take back over if you wish by restarting the primary node. Generally, it's not a setting that we utilize because usually you want to plan a better time for the business to actually move things back over. So what I'm going to do here is, again, show that the BMOFS file system is not there, and my other GLVM disk shows defined, not available. So if I look back over here, it tells me that, again, previously it showed me both disks were active, but they really weren't. So if I check the volume group status again now, it has detected the difference, and if I would have looked a little bit sooner, I would have showed that there would have been stale PPs, probably just one, maybe two, just because I didn't have a lot of data that was written from one and not the other. So if I do it without the flag and just check for stale, it tells me there's nothing stale. So if I look at BMOFS, my doc is still there. So now I will add another line as a test. And this time I'm just going to do a controlled move. I'm not going to do a hard failover. So I'm going to do that via CSPOC to move it back to the primary site. And in this case, make sure you choose the one that says online. And in this particular case, since I only have one node at each site, I could do it by node or by site. It's just common that you would probably use site when you actually have sites defined. So actually, if I go back and look at my cluster status while this is running, it's already letting go. It's bringing it down. So essentially what it's doing, so it's still doing its release, coming back up. I just paused that for probably about 20 seconds or so. It let go of everything on Node Jordan already. It's bringing stuff up on Jessica currently. You can see the service address is in place. And just like a normal local cluster startup, the processing order is very similar. It's IP address, volume group, file systems, and app. I don't have a real application on this setup, but you can see that GLVMG has active, and it's active with 2 disks, and I'll show that. And the cluster is stable. So if I look here, I see that my disks are active. I can look at my volume group status. Both are active. And if I go to my BMOFS, I should see that my second line of data now exists in the file. And there's my second line. So all this is showing is that the data was written, and on the failback, I'm actually accessing both copies of data anyway because it was a controlled failover. But the initial failure, when I did the hard failure, it could only access the copy of data locally on Jordan. So that was really just to show that it did indeed sync up and it was able to activate with only one disk available. So that pretty much concludes this demo as usual. If you have any questions, feel free to leave a comment. You're always welcome to send me an email at sbodley@cleartechnologies.net. And as always, thanks for watching.